Hey guys, hey boys and girls. Hope you are studying for our quiz tomorrow. Just wanted to go through some of these problems with you. So this was the first problem. We were given that L is parallel to M. So what we want to do here is we know that if this one's 90, we know this one's 90. And because we've already said that these are parallel, 2x minus 4 has to equal 90 because they are corresponding angles. Top right, top right. Add 4 to both sides. We get 2x is equal to 94. Then divide both by 2. And then x equals 47. And there's your answer. Next one, name pairs of parallel lines or segments. So we're going to first start off by finding any angles that we can. So this is 132, which means vertical angles 132. If this is 48, well, we know these form a line, so they're a linear pair. So this one is going to be 132. Then you got, so basically, we're going to look at two of these angles first. We've already figured out that that's 132 and that's 132. Well, if you look at these lines right here, we can use line L as a transversal. And if L is the transversal and these two angles are equal because they happen to be corresponding angles, that automatically makes N and P, these two lines right here, parallel because of the converse of the corresponding angles postulate. So we've already proven the green angles, these ones right here. Now let's go ahead and try to prove L and M parallel, which would be these in red. Well, if this is 132, this is going to have to be 48 because they form a linear pair. And if this is 48 and this is 48, and I'm going to use this black line right here as a transversal of these intersecting these red lines, we can see that the angles right here are both on the bottom right. They're corresponding angles, therefore, and they're equal. That would automatically mean that lines L and M are also parallel. Number 8 is right over here. It's a quadrilateral, and we see that this is 50 and this is 50. And if I extend my lines, both sides, and think of this as a transversal, which it is because it intersects, I'm just going to extend it, you can see that 130 and 50 are both on, are interior angles on the same side. So because we know that 130 plus 50 is equal to 180, well, that means that these lines right here are going to be parallel because of the converse of the same side interior angle theorem. Just to double check, is there any way for us to figure out, we know that these lines are parallel. What about these lines, DC? And if you look at the other angles, the same thing's going on. They have opposite, same side, interior angles, add up to 180. Therefore, we could prove that these lines are parallel because of the converse of the same side interior angle postulate. So next we got these two problems. What I would do right away is, since this is 55 and this is 49, add them up. You get 104. And since it's a triangle, we have to add to 180. So 180 minus 104 is equal to 76. So this angle right here is 76. I actually could have got that because of the vertical angles. I missed that one right there. And if this is 76 and this is 55, then this right here is going to be the missing angle. Well, 76 plus 55 is 131. And 131 minus 180 is 49. Now, here's how you're going to do this one. If I extend this line, this is my transversal, and then I'm going to put my parallel lines, or what I think might be parallel lines, in green. And just extend those. What you may notice is that this angle right here and this angle right here are alternate interior angles, and they happen to be equal. Therefore, we know by the converse of the alternate interior angles theorem, VZ and XY are both parallel lines. This one right here, if this angle is 70 and this angle is 72, I could figure out what this angle is by adding these two up and getting 110, and then subtracting from 180, which means this angle right here is going to be 70 degrees. Well, if we think of this as a transversal, if you look at these angles right here, these angles are all top right corresponding angles. Well, this is 70 and this is 70, which means the only two that are parallel would be this bottom line and this top line right here. This middle line would not be parallel because it has a corresponding angle not equal to the other corresponding angles. One more, and then I'm going to go on to another video. Refer to the figure at the right, find x, so we're saying that L and M are definitely going to be parallel. So I'm going to go ahead and highlight those. Now, if you look at this angle and this angle, you can't really make claims about these two angles right here, or this angle, because we don't know that P and Q, we don't know if they're parallel. All we know is that these two lines are going to be parallel. So we're going to use one of the transversals of these two lines. We're going to try this one. Now, what does this angle right here and this angle have to do with each other? Well, nothing right now, but if this angle is 3x plus 5, the vertical angle will be 3x plus 5. And now you have two angles on the same side that are in the interior. So we know the same side interior angle theorem states that if you add one to the other, they're going to be supplementary. So 3x plus x is 4x. 5 and negative 5 cancel out, so you get 180. And when I divide by 4, you get x equals, 4 goes into 18, 4, d5 times. And therefore x is 45. And that would have to be the value of x in order to make these two angles right here supplementary. And if they're not supplementary, then the angles wouldn't be parallel, those lines wouldn't be parallel. Now, next part, using the value you found in part A, determine whether lines P and Q are parallel. All right? Well, let's fill in the information we now know. If this angle right here is x minus 5, so this angle I could substitute in 45 minus 5 or just 40 degrees. This was 3x plus 5, so it's 3 times 45 plus 5. So 45 times 3, 135 plus 5 is 140. And I knew that also because they're supplementary. If that's 140, it makes this one 140. Right? Now, if you look at these two lines, this one right here is 45. This angle right here is a linear pair, so we automatically know that this one is 135 degrees. Well, if you look at this angle and this angle, they're corresponding angles, but they're not equal. Therefore, you cannot say that these black lines, in fact, they're not parallel.